Okay, hello world.
Yeah, you can introduce our guest.
Okay, hello world. I'm really happy to, actually we're really happy to have Zubin here. Is a graduate from MTech, student technology. And thank you for accepting our invitation. And now Zubin are helping us to doing actually GSS in Tehran notes. Thank you, Zubin.
Okay. So first, let me know how do I share the screen, and then
can start sharing.
how do I use it? You can see my screen now. Just a double check if you can see the screen.
Just don't ask all over.
Yeah, please tell me if you have any problems in the screen. So today I'm going to present some of the projects that we have working on so far, and I'm trying to keep it as short as possible because I know that everybody are quite busy at all the nodes. So going to I would present some of the previous works that have been working, plus a little bit of the theoretical framework regarding the projects that we were. So back when I was studying and I was working a little bit, it's a very example of the projects we were looking and we were studying. And kind of classical, always trying to investigate the properties of these projects and how do we able to model these kind of tools. We're using these kind of new tools, new kind of software platforms that we were working on. I try to develop that kind of examples of classical architecture using this kind of new media and to see how we could actually even fabricate this kind of stuff. For example, in these car band examples come from traditional Iranian like architecture. This to go through a little bit of experimentations that we have been working on so far in a couple of last 3-4 years. But before that, I started studying like classical architecture, trying to model it using digital platforms and understand the geometrical concepts and rules behind these kind of complex geometrical configurations, and to see how we could kind of imagine and kind of construct these kind of classical objects and see how new platforms could help us to develop these architectural projects. And then because of that, I tried to concentrate more on geometry and mathematics and to see the logics behind. So looking at this code from Robin Evans, that how advancement in geometry could eventually help us to develop art and architecture. And I really believe that this kind of advancement today is really related to the advancement of tools and based on that, on geometry and mathematics that we could explicitly use. So my talk has been divided into two parts. In the first part, I will talk about how architecture and mathematics being worked together so far, very quickly and briefly, and then showing you a little bit of our practice, that how we actually try to mix and match them together. In a very first part, architecture was geometry through projection, or let's say descriptive geometry, as a part of geometry as a branch. So in this very first use of geometry, architects were trying to project their designs into 2D spaces, so mainly drawings. And that was the very kind of interesting part, to see how 3D objects could be really projected into 2D. And then through projection, architects started to kind of visualize and to see how their models and how their ideas could be transferred into drawings and to be constructed later on in projects. But then later, the main topic for architects related to geometry was proportion. Like the little by little, when the styles of architecture have been progressed, you can see how proportions started to play like design roles in architecture. So, for example, what would be the ratio of the height of an arc related to its openings, or that kind of studies. And then there was this idea that God had created the world by establishing the principles of order and proportion. This is the quote from Jacques Benin-Boussois, a philosopher. And this is the moment where architects would actually think that they are having a sort of power being transferred from God to them. So architects would have a sort of a job that see these kind of proportions or like the order in architecture and try to convert it into physical environment. So proportion would be the next like sort of entanglement of architects and the science of geometry. But the next step would be for architecture and mathematics is proportion versus calculation. So in this part, a little bit of scientific studies started to appear, like more importantly in architecture. So, for example, here you can see that architects started to study the material behavior and to see, for example, what is the material strengths and how do we study materials and their behavior in relation to the physical laws. This material behavior started to be transferred into design practice, and to see how calculations could help us to design our projects rather than proportions. So instead of studying the rules of proportions, here material behavior or other kind of scientific studies of materials are starting to appear in the design of projects. So going through these very main three stages of the relation of architecture and mathematics, the next stage would be us these days dealing with explicit mathematical definitions, like using explicit definitions in our softwares like Rhino Grasshopper processing or whatever, and trying to see what kind of geometries and spaces we could generate through the utilization of this kind of like experimentations with explicit mathematics. So this is the new state of using mathematics in terms of the generation of space. And based on these new techniques that I'm sure that you're almost all familiar, we have been through a couple of different and we try to like design and fabricate a couple of different pavilions together with Meron, who actually, he's here actually. So these are projects that we explicitly use mathematics. And this is the first one that we work together, and hope you join me as well to do a little bit of more description. The very first the example that we have been through, we try to see if we have a geoid mathematical definition of a geoid surface. How do we use this kind of mathematical definition to develop a pavilion project? How we could actually refine the mathematical definition, and how do we like interpret it in a propagate it for it in a scale to see how this works. So there were couple of the different avenues of studies. First one was, as I mentioned before, how we design a project using a mathematics. And then on the parallel line, we were trying to develop composite materials that we could use in order to fabricate the model that we are developing on that stage. So a couple of our students started to explore how composite materials would work for the formation of these freeform kind of surfaces. And this is the example that we were working on our 2014 project back here in Tehran. And so it was our first try, and we have faced a couple of different problems and issues of form accuracy or material strength and everything, but we tried to actually overcome all the problems by continuing the project. This time we started on another form. Again, coming from the mathematical definitions, this time an edited version of Schwartz p-minimal surface. And we again started by the development of similar kind of strategies to see how these kind of thin surfaces could be addressed using these forms, also being a little bit manipulated in order to be able to incorporate other needs of the project. Because it was a pavilion, we wanted to walk inside, we wanted to have enough enclosure and that kind of property. So we started to manipulate the formula in order to see the output that could kind of benefit the needs that we wanted. So here you can see a catalog of some of the generated, and then we try to refine and get the best output out of the catalog of forms that we developed so far. So this is the imagination of our students. They wanted the external surface to be like a mirror, also having some internal kind of curvy shape. So in contrast to the previous year, in this time they wanted to have a sort of box as the exterior form who enclosed the surface, the curved kind of surface that we have inside the pavilion. This is a sort of MRI scanning, so you can of the project. You can see that we could walk inside. The internal space is big enough to have some people, to incorporate people inside. But for the fabrication phase, this is the process of fabrication for our previous project, 2014, because we wanted to transfer all the pieces from upstairs to this kind of gallery underneath inside it was a gallery, actually. It was a factory. So in an old factory. So based on the transformation restrictions, we subdivided the pavilion into very smaller parts. So the assembly would increase the number of errors that we meet usually. So for this year, for this pavilion, we tried to see how we could reduce the number of subdivisions, but also increase the quality of the surface that we are working. So we subdivided the pavilion into some parts and asked our students to assemble them together and enclose them with fabric formworks. As you can see, the waffle structure does not really work so much on the structure, but the main aim is to generate this double curved surface that we have covered with flexible formwork technology. And the composite materials have been applied to that kind of screen or that surface, and then it has been solidified on like the geometry that we really wanted. Are some of the issues that were used facing, and then we've had people who really worked hard to refine the edges, to get rid of all the gadget sort of edges of. I don't know if the video has sound over there as well or not. This is the video of the process that we have been through. Okay, I hope that you've had the sound of the video. I'm not actually sure about it. So I'm trying to present as fast as possible. So this is the last pavilion that we were working, this time with Plucker's conoid formula, and it has been again explicitly plugged in to a sort of algorithm that we were trying to develop our design project. Our idea was to look back at some Flick's candle laws, very interesting projects. We're using thin layers of concrete and developing that kind of concrete shells, and to see how we could really understand the logic behind and how we could use that kind of logic to develop our pavilion, this time using another technique of fabrication, which is hardware cutting of foam. Based on that, we tried based on a Plucker conoid, we designed the form that you can look at this slide, but also we tried to apply some because of the self-weight of the shell. So we try to optimize the thickness, and to get that thickness, we try to run a robot to cut that pieces for us. We actually had the help of the project who helped us a lot to work with this machine here to cut our pieces, although we also used another machine which was a 4-axis CNC hardware cutter to help us fast forward the fabrication process. Next, we transferred all the pieces into the University of Tehran to apply composite materials in both sides. So the material system was a sort of sandwich structure with a core of foam being covered with 2 coats of composites in both sides. Again, our students working all together to make sure that all the pieces will assemble together and get the final form. And this is the shell that they have been designing together and developing based on the story that I told you. And some of the images that you can see from this pavilion, which is from the last year's workshop that we had with Mehran and Kunal and all other friends together who are here as well. Again, I'm sharing the video. Hopefully you can hear the sound as well. Okay, so it was the last pavilion that we have realized together with Mehran and other colleagues, and as I mentioned before. So I would like to like wrap it up with a quote by Mark Boy, which I really like him because, and I know, I mean, you know him definitely better than me because he worked in Barcelona a lot, and he believes that. Mathematics is a sort of general tool in comparison with design, which is really specific. But these days, we have some problems which are universal, and we are trying to tackle all these problems, which are like, for example, environmental. And then mathematics is a very kind of great tool to help us to actually fight these problems that we are looking at. And this is the kind of belief that we can try to develop this in these workshops to see how we could use mathematics in order to design and realize our projects. And that's the main thing. And I try to shortly present to you guys because I know that everybody are quite busy. So thank you so much for listening and attending this talk. Thank you.
Okay, Federico. Wait. We can't hear you.
Wait.
Oh, wait.
Can we ask you some question about the lecture?
This is Abby, I think. Hello. Yeah. Hello, China.
Hello.
Can we ask you some question about
Hello, Tehran.
Yeah, for sure.
Hi, Ali. Can you hear me?
Salam.
I think they have some question from Barcelona. Do we have any question from Barcelona or should we finish here? Okay, great.
Hello. Was really great shape, but for me, there's some interest about how these shapes, these mathematical shapes, can we integrate in the use of the rural people? How can we integrate these kind of forms, like in the in like our normal lives? Because I think it's a very powerful tool, but I have to put this in like the direct relation with like another way to use.
Oh, look, can you tell us the question?
Yeah.
Because I can't hear the
I can hear you, but I cannot understand the question.
it's kind of noisy.
I'm going to try to repeat the question. I mean, the question is
Thank you.
how can you apply into architecture, meaning probably the building scale, these kind of techniques. So how can you embed somehow the complexity that you showcase in this pavilion into an architecture more, how you say, a more common architectural process?
Yeah, because as a pavilion, I already know how it works and it really works very fine. But it's very difficult to try to imagine how can we implement this kind of mathematical forms to like make a solution more spaces, for example, in a house, that has a lot of spaces and as a pavilion doesn't have. Very complex, like in programs, right?
I think it's
I think let me go ahead a little bit, and I hope that I got your sound well. Otherwise, you correct me again. I think the projects that we tried to realize was like, as you said, they're just pavilions. They are smaller scale. The material was only one material, like a composite or a single shell. So yes, it was quite feasible in that scale, and with single material, it would be really difficult in larger scales and with multiple kind of materials, like in an architectural project. I remember some examples, for example, from Toyo Ito, who actually used explicit mathematical definitions of periodic minimal surfaces, for example, or from Zaha Hadid architects who developed pavilion kind of projects with mathematical definitions. So you're right, it is not always easy to explicitly use mathematics to produce architecture, but I think there is a lot of potential over there. So what we tried so far is to see if this kind of materials could be kind of merged with mathematical design, and to see the potential, at least in this scale. But I'm looking at projects from Toyota or Zaha to understand the and for like processes better. So I definitely they are a lot more advanced than us. So hopefully it will progress forward. Perfect. It was enough for the question that you've asked, because there is a little bit of noise as well. So I try to compose something.
Yeah.
and also when you are working with such a complex geometry, then you have to comply with the needs of the task accuracy, to be responsive to the geometrical needs that all these basically. I'm using the microphone.
Yep. Yeah, unfortunately.
So what I want to say is that managing complexity, it's not only an exercise per se. I mean, it's a training that you develop, and then it's up to your project and your feeling as an architect to project into this complexity and meaning, functionality, and new possibility to respond to new needs. We saw different lessons in Canada. We saw NBRDB. They were thinking about space that open, close, reacts to the people moving, and the ability to control this complexity at the end becomes a new, opens up a new set of possibilities in architecture. It allows us to experiment with materials, allow us to experiment with space. Allow us to embed new programs into architecture. So at the end, it allows us to experiment with structures, with static, to push a little bit further the possibility of normal space, normal pavilion. So I guess it's all the process that goes even beyond the actual form, right? But the added value is the overall process that you showcase.
Yeah, exactly. Yeah.
Okay.
I think.
I don't know if we have another question from one of the notes. Ali or Moscow, Fernando.
So we keep dropping the sound, but if you can say it again closer to the microphone, please.
Sorry?
Okay, hello.
Hello, Ali.
So, fortunately, I'm very familiar with both projects. So,
actually, I've been
going to ask you.
Just don't try asking Farsi. Go ahead.
Okay, so the thing which I was kind of curious to see if it was become part of the presentation was actually at the end of Craft 2016, there was a lot of discussion about the proper way for tessellation of the Candela surfaces. And I wonder if there is more information available on that, and also like kind of techniques that you guys did, like a side, like for each panel. Yeah, and this could also be a good example of like how to set up these panels.
Exactly, you're right. Actually, it was a big challenge in front of us to see in what different kind of strategies we could subdivide the form. We tried it in 2 different methods, each related to the to the machine that we are going to use for our fabrication technology. So the first one was related to the robotic fabrication, but we also used another machine which was a 4-axis wire cutter. So the subdivision of the form was completely different for that one. So we tried to mix and match and see how these two could meet each other. And you're right, actually try to compact the presentation as much as possible, because they told me that they kind of asked me to present really fast and not take that much time. So, but I mean, I later I might have some documentation and that to share with the other guys in our websites and stuff. But yeah, you're right. We tried like really different methods to see.
Yeah, because I think that part was kind of missed in your presentation, and I remember last year it was quite interesting and challenging.
Yeah, you just compact everything to 30 minutes.
Yeah. But thanks for the notice. Yeah, it's true.
So any other question from all the nodes? I know Mexico.
Barcelona, that's it. Aside from the fact that I want to congratulate you, because I think that you are producing the most interesting outcomes from the workshop that I see around all over the world. I think that's the...
Thank you.
For the amount of time also that you have, it's impressive. Every time I really look forward from your result. And I'm not saying it just for the sake of the situation, you know. I'm a big
Thank
fan.
you.
Okay, guys. I mean,
thank you.
I'm very happy.
Thank you for participating in this global lecture. It was an honor.
Thank you so much for having us.
We just
for honor.
A last goodbye from Barcelona. So thank you.
Yeah, goodbye. Goodbye. Good work. Good rest of the